This is a bid for an electrical installation involving quad receptacles and an air conditioning outlet. Materials will include 12/2 EMT for the air conditioning outlet's home run, approximately 80 feet, and 12/3 EMT for the quad receptacle home runs, totaling approximately 160 feet for 2 runs. 1/2 inch EMT conduit will be necessary along with a single gang box with a raised cover. You will need 2 quad receptacles and 1 single receptacle, as well as the associated conduit fittings and connectors, wire nuts, and electrical tape. Labor will involve installing the 1/2 inch EMT through the floor and up to the receptacles, running the 12/2 EMT home run to the air conditioning outlet box, running the 2 12/3 EMT home runs to the quad receptacle boxes, installing the quad receptacles and the single receptacle in the boxes, connecting the wiring and securing the devices, and cleaning up the work area. The bid for materials is $150 and labor is $400, assuming 8 hours at $50 per hour for a total bid of $550. Additional considerations include electrical permits that may be required, inspecting the work area to ensure it is safe for electrical work, using proper safety gear, including gloves, safety glasses, and a hard hat, following all applicable electrical codes and regulations, testing the installation thoroughly before energizing the circuit. This bit assumes that the quad receptacles are close to the floor and that the air conditioning outlet is located at a reasonable height. If significant additional conduit is required, the bid may need to be adjusted. It's important to factor in travel time, cleanup time, and contingencies when determining the labor cost. Consider offering a warranty on the installation for added peace of mind. Firstly, determine the exact length of the wire runs needed for both the 12/2 for the air conditioner circuit and the 12/3 for the quad receptacle circuits. Account for vertical runs up the beam and through the floor, as well as the 6-foot run between the quad receptacles. Secondly, ensure that the wire gauge is appropriate for the anticipated load on each circuit. Typically, 12 American wire gauge copper wire is rated for 20 amps, but local electrical code should be consulted to confirm compliance. Thirdly, plan the routing of the EMT conduit to minimize bends and obstructions. Use appropriate bending tools and techniques to create smooth, gradual bends that do not damage the conduit. Fourthly, securely fasten the EMT conduit to the building structure using appropriate straps and fasteners. Ensure that the conduit is adequately supported to prevent sagging or movement. Fifthly, when pulling the wires through the conduit, use a wire lubricant to reduce friction and prevent damage to the insulation. Avoid overfilling the conduit, as this can make it difficult to pull the wires and can potentially damage the insulation. Sixthly, properly terminate the wires at the receptacles and within the electrical panel. Use appropriate wire connectors and ensure that all connections are tight and secure. Seventhly, clearly label all circuits and breakers within the electrical panel to indicate their function and the area they serve. This will aid in future troubleshooting and maintenance. Eighthly, before energizing the circuits, thoroughly test the installation to ensure that all connections are correct and that there are no shorts or ground faults. Use a multimeter or other appropriate testing equipment to verify voltage continuity and ground impedance. Ninthly, consult the National Electrical Code or local electrical codes for specific requirements related to receptacle spacing, grounding, and other installation details. Tenthly, obtain all necessary electrical permits before starting the work and schedule an inspection by a qualified electrical inspector after the installation is complete. This is very important. Let's delve a little deeper into some of those aspects mentioned. Consider the NEC requirements for spacing of receptacles. This is particularly important in a commercial setting to ensure adequate access to power for various equipment and appliances. The NEC specifies maximum distances between receptacles along walls to minimize the use of extension cords. The NEC also requires ground fault circuit interrupter protection for receptacles in certain locations, such as bathrooms, kitchens, and outdoor areas. Determine whether ground fault circuit interrupter protection is required for the receptacles in this installation, and if so, install the appropriate ground fault circuit interrupter receptacles or circuit breakers. We remember to consider voltage drop. Voltage drop occurs when the voltage at the load is lower than the voltage at the source due to the resistance of the wires. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Calculate the voltage drop for each circuit using the wire length, wire gauge, and anticipated load. If the voltage drop exceeds the recommended limit, increase the wire gauge to reduce the resistance. When using EMT conduit, ensure that all joints and connections are properly tightened and secured. Use appropriate conduit fittings and connectors to create a watertight and mechanically sound installation. Consider using set screw connectors or compression connectors for added security. When running conduit through the floor, use appropriate floor flanges or bushings to protect the conduit from damage and to prevent moisture from entering the conduit. Consider using a sealant or caulk to seal the floor penetration and prevent water from seeping into the basement. When selecting receptacles, choose commercial-grade receptacles that are designed for heavy use and are tamper-resistant. Commercial-grade receptacles typically have heavier-duty contacts and housings than residential-grade receptacles. Tamper-resistant receptacles have internal shutters that prevent children from inserting objects into the slots. Ensure that all wiring is properly supported and secured within the electrical boxes. Use appropriate cable clamps or connectors to secure the wires to the boxes and prevent them from being pulled or damaged. Avoid overfilling the boxes with wires, as this can make it difficult to make connections and can potentially damage the wires. When making wire connections, use appropriate wire connectors that are rated for the wire gauge and the number of wires being connected. Ensure that the connectors are properly tightened and that the wires are securely held in place. Avoid using improperly sized or damaged wire connectors. When working with electrical circuits, always disconnect the power at the source before starting any work. Use a voltage tester to verify that the circuit is de-energized before touching any wires or components. Wear appropriate personal protective equipment, including safety glasses, gloves, and a hard hat. Follow all applicable safety procedures and guidelines to prevent electrical shock and other injuries. When testing the installation, use a calibrated testing device to ensure accurate results. Perform a continuity test to verify that all connections are properly made and that there are no shorts or open circuits. Perform a ground impedance test to verify that the grounding system is properly installed and that the ground impedance is within acceptable limits. Perform a voltage test to verify that the voltage at the receptacles is within the acceptable range. Document the entire installation, including the location of all circuits, receptacles, and conduit runs. Create a wiring diagram that shows the circuit layout and the wire connections. Keep the documentation in a safe place for future reference. When determining the bid price, consider not only the cost of materials and labor but also the cost of overhead, insurance, and other expenses. Be sure to factor in a profit margin to ensure that the business is financially sustainable. Consider offering a warranty on the installation to provide customers with peace of mind and to demonstrate confidence in the quality of the work. A warranty can help to differentiate the business from competitors and can increase customer satisfaction. When dealing with customers, communicate clearly and professionally. Explain the scope of the work, the timeline, and the cost. Answer any questions that the customers may have and address any concerns they may raise. Be sure to obtain written approval from the customers before starting any work. It is also crucial to choose the correct type of EMT fittings. Compression fittings create a watertight seal and are suitable for use in wet locations. Set screw fittings are less expensive but may not provide as tight a seal. The choice depends on the specific application and local code requirements. Branding is another critical aspect. All metallic components of the electrical system, including the EMT conduit and the metal boxes, must be properly grounded to provide a safe path for fault current to return to the source. Use grounding bushings and jumpers to ensure continuous grounding throughout the system. Consider the placement of the air conditioning outlet. It should be located in a convenient location for the air conditioning unit and should be accessible for maintenance. The height of the outlet should comply with local codes and should be high enough to prevent accidental damage. Before starting the installation, perform a thorough inspection of the existing electrical system to identify any potential problems or hazards. Look for signs of damaged wiring, overloaded circuits, or other electrical issues. Address any problems before proceeding with the new installation. It is also important to consider the ambient temperature in the basement. High temperatures can affect the ampacity of the wires, so it may be necessary to increase the wire gauge to compensate for the temperature difference. Consult the NEC for ampacity correction factors based on ambient temperature. When running conduit through walls or floors, use appropriate fire-stopping materials to maintain the fire resistance of the building. Fire-stopping materials are designed to prevent the spread of fire and smoke through openings in walls and floors. Consider the potential for future expansion or modification of the electrical system. Install extra conduit or pull extra wires to accommodate future needs. This can save time and money in the long run. It is essential to use the right tools for the job. Invest in high-quality tools that are designed for electrical work. Use insulated tools to protect against electrical shock. Keep the tools clean and well maintained to ensure optimal performance. Always follow the manufacturer's instructions when using any electrical equipment or tools. Failure to do so can result in damage to the equipment or injury to yourself or others. Consider the use of arc fault circuit interrupter protection. Arc fault circuit interrupters are designed to detect dangerous arcing faults in electrical circuits and to energize the circuit before a fire can start. Arc fault circuit interrupters are required in certain locations by the NEC. Use appropriate labels and markings to identify all electrical components and circuits. Clearly label all circuit breakers, receptacles, and switches. Use warning labels to indicate potential hazards. This will help to prevent accidents and to facilitate future maintenance. Consider the use of surge protection devices. Surge protection devices are designed to protect electrical equipment from voltage surges caused by lightning or other electrical disturbances. Surge protection devices can be installed at the electrical panel or at individual receptacles. When working in a commercial building, be aware of the specific electrical requirements and regulations that apply to commercial installations. Commercial electrical systems are typically more complex and require a higher level of expertise than residential electrical systems. Consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes and regulations. Remember that safety should always be the top priority when working with electricity. Take the time to plan the work carefully, to use the right tools and equipment, and to follow all safety procedures. If you are not comfortable performing the work yourself, hire a qualified electrician to do the job. When estimating the labor cost, consider the complexity of the installation, the accessibility of the work area, and the potential for unexpected problems. Be sure to factor in time for travel, setup, cleanup, and inspections. It is also important to consider the cost of workers' compensation insurance and other business expenses. When presenting the bid to the customer, be prepared to explain the scope of the work, the materials being used, and the reasons for the cost. Be honest and transparent in your dealings with the customer, and be willing to negotiate if necessary. It is also important to get everything in writing. Use a written contract to document the scope of the work, the materials being used, the costs, and the timeline. Have the customer sign the contract before starting any work. Keep a copy of the contract for your records. After completing the installation, perform a final inspection to ensure that everything is working properly and that all code requirements have been met. Clean up the work area and remove all debris. Provide the customer with a copy of the wiring diagram and any other relevant documentation. It's also a good idea to follow up with the customer after a few weeks to ensure that they are satisfied with the work. Address any concerns or problems promptly and professionally. Building a strong reputation for quality and customer service is essential for long-term success in the electrical contracting business. Furthermore, consider the use of smart receptacles. Smart receptacles offer advanced features such as energy monitoring, remote control, and surge protection. These receptacles can be integrated with home automation systems and can provide valuable data on energy consumption. The cost of smart receptacles is typically higher than standard receptacles, but the added features may be worth the investment for some customers. Additionally, think about the color coding of wires. The NEC specifies a color code for electrical wiring to help identify the function of each wire. Typically, black wires are used for hot conductors, white wires are used for neutral conductors, and green wires are used for ground conductors. Follow the NEC color code when wiring receptacles and other electrical components. It is also important to consider the torque specifications for electrical connections. Over-tightening or under-tightening electrical connections can lead to loose connections, overheating, and electrical failures. Use a torque wrench to tighten electrical connections to the manufacturer's specified torque. Consider the use of wire pulling lubricant. Wire pulling lubricant can reduce friction and make it easier to pull wires through conduit. This can save time and effort, especially when pulling long runs of wire through multiple bends. Consider the use of a fish tape or wire snake. A fish tape or wire snake is a tool used to pull wires through conduit. It is a flexible metal or plastic tape that can be inserted into the conduit and used to pull the wires along. This is very helpful. Consider the use of a vacuum cleaner to clean out conduit. Before pulling wires through conduit, use a vacuum cleaner to remove any debris or obstructions from the conduit. This can help to prevent damage to the wires and to ensure that the wires can be pulled easily. And let us talk about the use of a stud finder. When installing electrical boxes in walls, use a stud finder to locate the wall studs. This will ensure that the boxes are securely mounted and that the wires are protected from damage. Consider the use of a level. When installing receptacles and switches, use a level to ensure that they are installed straight and level. This will improve the appearance of the installation and will prevent the devices from being damaged. Also consider the use of a plumb bob. When installing conduit runs vertically, use a plumb bob to ensure that the conduit is installed straight and plumb. This will improve the appearance of the installation and will prevent a conduit from being damaged. And most definitely think about the use of a measuring tape. Use a measuring tape to measure the distance between receptacles and other electrical components. This will ensure that the devices are installed in the correct locations and that the installation meets code requirements. And finally, remember the value of using a camera. Take pictures of the installation before and after it is completed. This will provide a record of the work that was performed and will be helpful in case of any future problems.